We'll wait until tomorrow to do the rest of it. Okay, so we're going to add to today's, yesterday, or Friday's assignment and put today's on it. So first of all, we're going to talk about one-sided limits. And so they want us to find the limit as x goes to 0. And here's that new symbolism that I'm talking about. What does this little guy mean? You see the little minus sign there? Okay. It's a way of saying the limit as x goes to 0 from the left. Does that make sense? From the negative side. Okay. And this is the way of, and this is going to be the way to say the limit as x goes to 0 from the right. Okay. So we're going to evaluate the limit as x goes to 0 from the left of the absolute value of x over 4x, and then the same thing as it's going from the right. So we're going to start by creating a table. So what number shall we plug in for x? Can't do 0, right? 0, 1, and 2, okay? Because if we try to take the limit as x goes to 0 of, we have a 4x in the denominator, it'll make it a 0 in the denominator. All right, so we're going to plug in negative 2. So the absolute value of negative 2 over 4 times negative 2 is going to get us, what's the absolute value of a negative 2? And what's the absolute, or what do we get when we multiply 4 by negative 2? So our net result is negative 1/4, negative 0.25. Now we'll plug in a negative 1. So absolute value of x over 4x again, now it's a negative 1. We've written that. And when we take the absolute value of a negative 1 we get, and we divide that by 4 times negative 1, negative 4 again. Okay, let's try 1. The absolute value of 1 is, and then 4 times 1 is, and then the absolute value of 2 is 2. 4 times 2 is, and that reduces to. So let's graph what we have so far. Looks like it's a straight line. So negative 2, negative 1/4, we're 2 to the left, 1/4 of the way down. And negative 1, negative 1/4. Can't be 0. At 1, we're a 4th. At 2, we're a 4th. You need to plug more numbers in to see what's going on, or you're convinced that it's always going to be a 4th of some sort. Everybody okay? Or do you want to see another one plugged in? Yes, at 0 we're going to put an open circle. Then we're moving it to the left, straight line, to the right, straight line. So when we evaluate these two limits, the limit as x goes to 0 from the left of the absolute value of x over 4x is going to be what? What's it approaching? Negative 1/4. And what's the limit as x goes to 0 from the right as of the square root of the absolute value of x over 4x? Positive 1/4. Make sense? Okay, so nothing specifically new. We've been doing this for a few days now, since last week, but we have new notation here. Okay, so questions on this one? All right, so one more time to formally present it. A limit exists if and only if both the left and the right behavior converge on the same number. Make sense? So if f is a function and c and l are real numbers, then the limit as x goes to c of f of x will be L, provided the left limit and the right limit are the same. Have to be converging on the same numbers. Okay, we've been talking about that all week. Okay, so let's try this one. Piecewise function. F of x is equal to x squared plus 1 when x is smaller than 2. And f of x is equal to a negative 1/2 x plus 6 when x is greater than 2. Okay? So let's think about what our table of values would look like. And let's call it so what numbers shall we plug into our first chart? And then 2 we have to be careful with, right? Because it can't actually be 2. Okay, can't quite be 2, so we'll put a star here to remember that one. Okay, what numbers will we put into our other chart? 2 with a star, and remember that we're doing something special with that. 3, maybe 4. Okay, so far so good? Okay. Now, when we plug negative 2 in, we'll have a negative 2 squared plus 1. So negative 2 squared is plus 1 is, so we're going to have a 5. When we plug negative 1 in, negative 1 squared is, plus 1 is. When we plug 0 in, 0 squared plus 1. We plug in 1, we get, and when we plug in 2, we get 5. Okay, so let's plot those. Now we have to be careful with this one. So negative 2, 5 is one of our points. And then negative 1, 2, and 0, 1, and then 1, 2. And then when we get to 2, we can't actually plug in 5. We can have an open circle there, saying that we can't actually be that number. So what shape or what type of equation do we have on this left side? Quadratic parabola, right? Okay, so we want it to come on down and then turn and go up. Okay, that's the left side. Now let's plug in our right side. When we plug in 2, negative 1/2 times 2, 1 plus 6, or minus 6, or negative 1 plus 6, 5. Now negative 1/2 times 3 is going to be negative 3/2, negative 1/2, plus 5, positive 3.5, right? And then 4, negative 1/2 times 4, negative 2 times, or plus 6. Keep writing the wrong numbers in here. Negative 1/2 times 4 plus 6 is going to get us 4, right? All right, let's pick one more number. Let's pick a good number then, right? Let's try 6. Okay, negative 1/2 times 6, 3, negative 3 plus 6. All right, so now we've got an idea of what's happening here. 6, thank you. Should be adding 6 each time. So 6 and a negative 1.5 is 4.5. I said the wrong number. It was my fault. I take ownership of that. Okay, he was just answering what I was saying. Okay, so we are 2 over and 5 up. So there's that open circle again. And then 3 over and 4.5 up. And 4 over, 4 up. 6 over, 3 up. So what do we have on this side? A line. Slope of negative 1/2. Okay, so let's talk about limits. The limit as x goes to 2 from the left of f of x is what? Good, because as x is approaching 2, we want to know what value of y is that approaching. It's 5. The limit as x goes to 2 from the right of f of x is also 5, right? So does the limit exist? Yes. And the limit is 5. Because those numbers are the same, the limit is 5. Make sense? So you want to basically tell me from the left it was 5, From the right, it's also 5, so the limit in general is 5. Does the function exist at 2? No. We have an open circle there. But the limit exists because both sides are converging on the same number. Make sense? Questions? Okay. So last example means we're going to take it in and use our step function that we haven't seen since chapter 1. So this is kind of typical of the package industry, okay, shipping industry. They're saying, hey, guess what? We have a package overnight. If you're going to ship it in one day overnight, the charge is $9 for the first pound. Okay. We have to label it, pick it up, or you drop it off. We have to get it into a truck, maybe on a plane. We're going to charge you $9 for that first pound. Have to hire people to deliver it. We have to have our computer systems that track it and let you know where that package is on your phone and all that fun stuff. So this is all bundled into that. Once you get to 10 pounds, it's $1 more. And once you hit 11 pounds, it's another $1. So then, of course, it gets more, more weight, it has more cost to it. So we want to show that the limit as x approaches 3 does not exist. So here's our function. F of x is 9 when x is between 0 and 1, not including 0. And then it's 10 between 1 and 2, not including 1, and so forth. Okay? So if y equals 9, what is that as far as the graph is concerned? A straight line. Horizontal or vertical? Horizontal. Okay, it goes parallel to the x-axis. The x is changing, the y is not. So when x is 0, doesn't cost anything. But when x, up until the point when x is 1, we're going to have a cost of $9. Then the minute you hit 1 pound, 1 ounce, or anything over 1, then suddenly it's now $10, right? So y is 10 is a horizontal line. Open circle here. It doesn't cost us $10 until we get a little bit above that. And it's going to be the same until we hit 2 pounds. And then at 3 pounds, it's going to cost us $11, 2 to 3. And from 3 to 4, it's going to cost us $12. And so forth. Okay? So we've got our graphical representation. What is the limit as x goes to 3 from the left? $11. From the left-hand side, as x is approaching 3, we're $11. Make sense? Okay. But the limit as x goes to 3 from the right of f of x is 12. Are they the same? No, so the limit does not exist. Make sense? That's what you're doing today. It's kind of a combination of the stuff that we've been doing, some graphing, some tables, and so forth. But it's showing that left-hand limit and right-hand limit are either the same, therefore the limit exists, or they're different, so the limit does not exist. Make sense? All right, here comes the assignment.